We're going to do problem B right now. Just put it wherever you want. Obviously, there might not be room on the sheet. I apologize for that. But really, I have to be honest, I don't really feel that bad. So, well, I'm just saying, like, I have I know I'm not going to be perfect on a given day. So if I happen to put together some notes that have a little bit more space, and so be it. We'll ask Jake and Carter. Does your professor give you handwritten note or notes that you can use to fill in the blanks? No. There you go. So I don't feel bad for you. What? No, he didn't. It didn't show up on my computer. Jace, when's your birthday? See, exactly. I told you he doesn't even have a birthday. Okay, it's probably like February 29th or something. February 30th. It's February 30th. There's no February 30th, therefore he doesn't have a birthday. All right, Jace, we'll get you tomorrow. Okay. All right. What? Learning targets? I just keep them up there in case somebody walks in the room. That way they. You guys know what we're doing, okay? Right? Every day, I can do the chain rule, right? Like it's right there. You guys ever walk in this class and say, "I don't think we did anything today"? All right. Like, how many times during the day do I say, "We're going to do the chain rule"? We're going to do the chain rule, right? I mean, like we know what we're doing every day, right? So yeah, here's what I want to do. Instead of somebody looking to see if I have my learning target posted, I want them to pull one of my students out and say, "What is the teacher teaching about today?" And you guys would immediately say, "Today we're teaching about the chain rule." Exactly, and that's more important, right? That's more important. And so if I can't be confident in that, then I got to change what I'm doing. So anyway, here we go. Let's do this problem. We'll try to get you guys some work time today. Tomorrow, no lesson at all, full work day. Okay. F of x equals square root of 2 minus x over 2x plus 3. I need to use the chain rule. What other rule do I need to use? Quotient rule. What does he need to use a quotient rule? There's a fraction. Awesome. Do I set up the chain rule first or the quotient rule first? Uh-oh, we are divided, YouTube. Raise your hand if you think it's the quotient rule first. Raise your hand if you think it's the chain rule first. Oh, does somebody want to make a case? B. Raiden. Okay, Braden was on an excellent, excellent track and then he backed down. Okay, I'm sorry, dude. All right, Riley, you want to state your case? Okay, so you're saying if you follow order of operations would be divide first, then at the very end, take it to the 1/2 power. So raising that thing to the 1/2 power would be the chain rule, correct? Exactly. So we set up the chain rule first. See it? Let's set it up. All right. So what's the inside? What's the outside? U to the 1/2. Awesome. Way to go, D. Weiland. Proud of you, man. Let's do the easy derivative. Derivative of u to the 1/2. 1/2 roots of u. One of my favorite parts of the year is where you just know that the derivative of u to the 1/2 is 1/2 roots of u because you don't say 1/2 u to the negative 1/2 anymore. You do some of those steps together and you're thinking about it. I'm very proud of you. That arrow be messing me up, man. it's like it's like you're teaching in North Minneapolis, man. It's like you're funny, dude. All right. Okay, so let's do the difficult derivative. In order to find this derivative, what do I have to do? Quotient rule. Oh my goodness, I'm gonna need some space here, aren't I? I'm gonna kind of use the space over here. Derivative of the top is -1. Oh, negatives. Why couldn't you just make it x plus 2? Why did he have to make it 2 minus x? Oh. Times 2x plus 3 minus 2 times 2 minus x. All over 2x plus 3, that quantity squared. Ugh. Well, I feel confident about this. 2x plus 3 quantity squared. I really like that part, but the numerator. Man. Best, I guess I better distribute and combine like terms, huh? So that'll be a negative 2x. It'd be a negative 3. Looks like it'd be a negative 4 and a plus 2x. Is that right? Oh, the x's cancel? Wow, it is a beautiful problem. Beauty is in the eye of the beholder. Negative 7. Rowan, I talked about you last hour. You're going to have to remind me to tell the story, okay? All right. Okay, what now? I don't even know. Oh, you want to plug you want to plug in that U thing, huh? Okay, so we'll plug in that U thing. I'm going to kind of bring this down here. We can see that this is going to get disgusting, but remember, this is algebra, your favorite subject. Like the calculus is done, right? This is now all algebra. So that beautiful subject that you all love, it's on. 1 over 2 times, and I'm going to write this as 2 minus x to the 1/2 over 2x plus 3 to the 1/2. I mean, if I take the square root of the whole thing, it's the same thing as taking the square root of the top and the bottom, right? The reason why I did that is because I want to multiply by the reciprocal and get rid of this stupid thing. Well, we'll do that, but I'm gonna take the reciprocal of this guy first, okay? This is a free country, I want to. So if I multiply by the reciprocal, what's in the numerator? Yeah, 2x plus 3 to the 1/2 over 2 times 2 minus x to the 1/2. Now we're going to do what D. Weiland said. We're going to take that. Now I've simplified the complex fraction. We're going to multiply that by what? Yeah, you got that negative 7 over 2x plus 3 to the 2nd power. Am I done? Why? Okay, all right. So Chris brings up a good point. He says you got to rationalize the denominator. Unfortunately, for the first time this year, he's incorrect. We we're okay with a square root in the denominator as long as there's a variable involved. Okay, as long as there's a variable, we don't really care. But there's something else that you should be drawing your attention to. Are those common bases? Are they common bases? So what do we do with common bases? What do we do with the exponents? We subtract them, right? So what's 2 minus 1/2? 3 over 2. Is it going to be in the numerator or denominator? Denominator, yeah. So so we're going to have negative 7 over 2 times 2 minus x to the 1/2 times 2x plus 3 to the 3/2. And that would be our derivative. This guy right here. So I got 1 over 1 on top. Got this on bottom. Can multiply by the reciprocal. Got it? Sure. Kind of an ugly problem, huh? Yeah, I get it. You know, fractions come up and our mind just goes to dirt. It's just like we can't even think anymore, right? Okay. Yeah, put the two tennis buddies together. Look at that. Thought you guys could talk tennis. All right, flip it on the back side. Here we go. Yeah, I thought about the two smartest math people in the classroom. I put them right together. So All right, so we've done kind of the chief examples that you would see, all right, both on my test as well in the AP exam, and we know that the algebra is rigorous. But suppose you get this type of example. This is one that the AP exam would love to give you, and the nice thing is it's super easy. But the fact is that I would bet that the majority of people seeing it get it wrong, and let's understand why. It says W of x is equal to U of V of x. Find W prime of 3 given the following values. Where do you even start? Here's where you start. You start by seeing that it's a composition function, right? Well, what did I tell you is the rule for the derivative of the composition function? Chain rule. So we take the derivative of the inside. What's the inside? So V prime of x times the derivative of the outside. So that would be U prime of V of x. Because we leave the inside alone, right? So understand now, it's like, oh, well, that's, Mr. Gibbs, we haven't talked about that a lot. Well, that is the chain rule, the derivative of the inside times the derivative of the outside with the inside left alone. So we need to plug in 3 for that then. So V prime of 3, do we know what V prime of 3 is? What is V prime of 3? Yeah, you see it right here, because we got V prime of 3. We got that guy right there. So we've got negative 3 times. Now, do we do U prime first, or do we do V of first? So now I got to do V of 3. What's V of 3? Yeah, you locate that. You're like, well, that's 5. So this becomes U prime of 5. So I'm almost done. I got negative 3 times. Yeah, it's negative 4. You get 12. Sorry, YouTube, for the pause. We're trying to debate whether the answer is 20 or negative 12, and I don't want to draw attention to it. So there we go. All right. What do you think? Not see? Hey, easy problem, right? Once you see just the little trick. Okay. Suppose they gave you a graphical representation. I love this. We've seen this before. We did this with the product rule, didn't we? Let's do it now with the chain rule. It says let U of x be f of g of x and w of x be g of f of x. Find u prime of 1 and w prime of negative 2. How about I do the first one, and then you do the second one on your own? Let's do it. So u prime of 1. Well, it says that u of x is equal to f of g of x. So therefore, u prime of x would be, let's do the same idea. What would we do? Good. G prime of x. F prime of g of x. Excellent. There we go. That's our derivative using the chain rule. So I want to compute u prime of 1. That's going to equal to g prime of 1 times f prime of g of 1. Okay. Got to find g. Here it is. G prime of 1. What's the derivative of the g function at 1? What is it, 2 or 3? Why? You're looking at the slope. Slope is 3. Times f prime of, now I got to do g of 1. What's g of 1? It's 2, right? The height of g at 1 is 2. So I'm almost done with this. Now I do 3 times f prime of 2. So now I look at 2, and I look at the derivative of f at 2. Negative 2. So I get negative 6. So now it says g of 1. So that means I locate the height of g at 1, which is 2. So I substitute 2 in for g of 1. So I'm now looking at f prime of 2. Negative 2. Better? Okay, you guys try u prime. U prime and negative, or w prime and negative 2. W prime negative 2. Go. GG, go! Hurry! See, she's on YouTube. Get it? She's probably eating popcorn, watching Netflix. Kind of got Gens going on the side. Just, I'll pay a little bit of attention. Whatever, GG. Yes, no? Tamara? Okay, thank you. Let's talk about it. So, did you get the f prime of negative 2? Good. So then I have f of negative 2. So that means I locate negative 2, and I locate the function f at that spot. And the height of the f function is 5. Can you tell me what you did? Okay. Got it. Okay. All right. Very common mistake. Very good. Guys, this is tough stuff. You're trying to understand algebra, tables, graphical representation. Like, not anybody could just sign up for this course to do this. This is tough stuff. Fortunately, you guys are all capable, which is awesome. Yeah. Yes. G of 2 is a corner. It is. So if it asks you for G prime of 2, you would say it does not exist. But at no point do we come up with G prime of 2. Same thing? Exactly. I will admit, okay, I'm glad you guys both brought it up because for some reason, my eyes were drawn right away to 5, and I saw a corner as well. Now, I worked through it, and I tried to stay, and 2, I was worried that I would kind of get caught up. Excuse me, smoker's cough. Whether it was g of x or f of x, I got to figure out which one it was. As you can see, f is on the bottom, g is on the top, but then it switches, right? So I thought I might get confused with that. So, but yeah. If you get well, let's be clear. If can you do? Suppose it asks for this. Suppose it asks for f prime of g of 2. Is g of 2 at a corner? Can you evaluate a function at a corner? Yes. Can you evaluate a derivative at a corner? No. If you came up with g prime of 2, then you would say does not exist because you can't determine it at a corner. Better? Good. You guys are doing well. All right. Let's finish it off. Great. Find the equation for a line tangent to the given curve at the given point. 2x minus 3 to the 5th power at 1, negative 1. Okay, in the old day, what would you have to do? You have to multiply it out 5 times, right? Remember? Zeno, right? Zane multiplied that 1 minus x out 10 times. And he got it right, okay, because he's a superstar. Way to go. Well, yeah, I used Pascal's triangle, but he had to account for the fact that there's a negative in it, so that ends up flipping every sign as well, which is what a lot of people make mistakes on. So, way to go, Zane. So, hey, this is easy. As soon as you see phi equation for line tangent, what do? Slope and point on the line. Sweet. Let's roll. What's the point on the line? Boy, that was easy. Yeah, it's almost like it was there. What if they didn't tell you it was 1, negative 1? What if they just said at 1? You plug it in and produce a y value, but everybody was able to do that. I think we're past that. Good job. So now we got to do the slope. And how do I find slope? Chain rule. You take the derivative. So I'm going to set the chain rule. What's the inside? 2x minus 3. What's the outside? U to the 5th. Derivative of u to the 5th. 5u to the 4th. Derivative of 2x minus 3. 2. Multiply them together. 10 times 2x minus 3 to the 4th power. Now what? Plug in 1. Yeah. This tells us the slope at any point. Plug in 1. Very good. 2 times 1 is 2, minus 3 is -1. -1 to the fourth. 1 times 10. 10, piece of cake upside down. Y minus y1, which is y plus 1, equals m times x minus 1. On the AP exam, you can actually leave your answer just like that. Never have to put it in slope-intercept form. You can just leave it like that. Exactly. On our test, we're going to make sure we put it in slope-intercept form. Y plus 1 is equal to 10x minus 10. Or subtract 1. Y is equal to 10x minus 11. Oh, no. Mr. Getz is a jerk. He's always pressing people to go further. I got extra time on my test. What should I do? How would I check my answer? My calculator? Are you nuts? How does that even work? Your calculator lets you do calculus? I don't believe it. They're not. Oh, no, the barcode function. I just showed my college algebra class that. It's some of those. You don't even remember what is my favorite, Grace? It's the sign of the reciprocal function. Gosh. 2x minus 3, and we raise it to the 5th power. I'm going to zoom standard, zoom 6. Calculator's finally dead. I don't have my axes on because I was messing around with some other stuff, but no big deal. And now I graph the equation for the line tangent, which is 10x minus 11. Let's check out the graph. Does it look like it's tangent right at that spot? Oh, I like the way you think. It's like you're being tortured. Settle down. This is torture. Oh my gosh. I have to zoom out a little bit. Okay. All right. Now you guys are just playing around with me. So, all right. There you go. Here's the deal. I am working on finishing up the answer key for this. You guys have right now 20 minutes to work on this, and then tomorrow you get an additional full day to work on this. If you come to class on Monday and you don't have your homework caught up, I don't feel bad for you at all. You should get a couple days in there. So, all right. Yeah, go to your locker.